Hi everyone. So great to see you here. Thanks a lot for coming. I'm really happy today that we are again hosted by Dynatrace. Thanks a lot. And that we will hear more about zero waste cloud computing. But before that, some housekeeping rules and I hand over to Andreas.
All right. So, first of all, for the one or two people who don't know or might not know what Dynatrace is, we are one of the market leaders in the field of observability, and our mission is to create a world where software runs perfectly, and we recently added also securely. We were founded 2005 in Linz and now expanded through whole of Austria. We have labs in Poland, in Barcelona, across the world. We are now about 4,300 people and I think 1,400 developers. And our target market are just the biggest companies. So I think more than 70 of the Fortune 100 companies are already our customers. So we are the observability solution for the big players. You can think of us as the debugging tool for your production system. Although you could, of course, also use us in your staging and other environments. And what we provide is an automated way to discover problems within your infrastructure.
Thanks a lot, Andreas. And as always, we start with open news. So those people who have been here before know what's the deal here. We discuss things that happened in the last month. So if you have anything to throw in, you throw the news and I throw the mic. Just need to catch it.
I mean, biggest news up front.
Yes, of course. Biggest news, please.
Biggest news up front. Kubernetes 1.27 was released. And that, what was the code name? Lazy, what was it? No, Chill Vibes was the code name of the release, I guess. It contained quite a lot of features, and it was one of the first times there were no hiccups during the release, so the chill vibes really
nice.
were true. One thing that was interesting for me was it now provides in-place vertical pod autoscaling. So that means previously, when you wanted to vertically scale a pod, it needed to be recreated, but now it can change its resource limits without needing to be destroyed and recreated. So for those of you who are running Spring Boot services that take 30 seconds to start up, that's a game changer, I would say.
Nice. Other news. Yes, of course.
I could now list all the features
yes.
of the. I would recommend everybody to listen to the Kubernetes podcast by Google because they list all the news that happened in this release, and I would have to look them up myself as well.
Great. Something that was quite big, discussed at least on social media, was the blog post by AWS.
Oh yeah.
Moving from microservice to a monolith. Who read it? Who read it? Everyone, right? Nearly everyone. What do you think about that? Any comments? Yes, please.
So we were discussing the topic yesterday in our team stand-up, and because we are working on the serverless monitoring solution in Dynatrace, and one of the colleagues said that they were using it actually for video processing tasks, and the thing was that you only have the possibility to get limited, I think 250 megabytes. You can transfer between the S3 bucket and the Lambda, and so they had to do a lot of data exchange, and this was very expensive. So it was not that the serverless, so the microservice architecture itself was bad, but for this task it was not appropriate, I think.
I mean, in hindsight, it feels obvious that you should not shift around big chunks of data between multiple services, and you might have thought, could have guessed that it would be cheaper to have one or a few services managing this data, or rather get the compute to the data instead of the other way around.
There's an interesting thing. There was a blog post that posted by AWS, by the way, from an internal AWS working group. And I'm sorry I can't show you now, but when I have the laptop, maybe I have it open and I can show you afterwards. And the interesting thing is that this working group, their job was to find out how much their own services cost. This is not a joke. It's an official blog post. So they said that it's super complicated how many services they already have, and they totally lost track of how much traffic shipping in from one service to the other costs. And so they created a really big graphic where you see how much you need to spend when you ship data from one service to the other. And I think that was, I mean, the blog post is older, but I think that was one of the reasons, of course. Then there's another interesting blog post that was released, I think, last week, that, of course, also by someone working for AWS, of course, you can move to a monolith if that's what you need. And by the way, they didn't move everything, so they still have lots of microservices. They just moved a tiny bit and reintroduced the monolith there. But definitely big news, yeah. Matthias Patzak, you can read Matthias Patzak on LinkedIn. He posted to the blog post. All right. Any other news or comments? I have to look on my cell phone too.
I mean, the thing that Kubernetes tries to over-communicate is the shift to a different repo. It will be a big red banner on top of the Kubernetes docs page. It's not, you cannot miss it. But they're shifting all of their images to a different infrastructure to hopefully make sure your deployments will deploy faster, since it will be more geo-separated. So I think that's a very big change they're currently trying to get everybody aware of. I'm not sure when the old repos will be shut down, but since this is all open source, I guess the funding is limited, and they would rather want to do this sooner than later.
Nice. The blog post I was referring to is called Monoliths Are Not Dinosaurs by allthingdistributed.com, if you want to look it up. Something else that I think we should cover in a session. Have any one of you heard about MRSK, M-R-S-K? No. Look it up. It's super interesting. The founder of Ruby on Rails, always forget his name, I'm really sorry about that, developed MRSK, and it's a very interesting way to manage your Docker containers very easily with auto restart, with auto deploy, but without Kubernetes. MRSK, definitely something to look out for, and the mail service hey.com is using it already. So
is this a competitor to Kubernetes?
No, it's not a competitor. It's more, if you need something that's not that much of a beast,
okay,
then MRSK could be your solution.
Could also be seen as a sign that Kubernetes itself got too complicated.
Did it get too complicated? Or
maybe it has the wrong defaults if people are looking for easier solutions to get started.
The interesting thing is that lots of people said Kubernetes is complicated, and they're saying it for years. But when Kubernetes started, I think it was a great alternative to the existing things like DCOS and stuff. And is it complicated? It's declarative, it's objects.
It's beautiful if you like YAML.
You have Sonnet that you could use if you don't like it.
True. Maybe one piece of news. It's still in its infancy, but if you have issues with your Kubernetes cluster and for a change it's not DNS, you might want to use K8s GPT to figure out what's going on. That's a new open source tool that you can throw at your Kubernetes cluster, and it will try to analyze and explain in plain English what the issues are and how you might fix them. And they even obfuscate the YAML they will send to OpenAI, which is of course behind all of this, so you don't leak any keys or private information about your setup. So
Nice.
it's K8s GPT.
Other news. Does anyone of you have news and wants to share them? Neil Ford is coming to Vienna, by the way. Codecraft. It's organized by Square, and it has a one-day workshop with Neil Ford. So anyone who wants to see Neil Ford in person, I do, and I bought a ticket. Buy a ticket. Yes, you raised your hand.
So I was trying ChatGPT 4 to build stuff in for SharePoint, and I had never built anything for SharePoint before, so I went on there and asked how to do it like one line. How do I upload files into SharePoint using, I think it was Azure or something. It gave me a whole bunch of instructions, and I spent like 2 days implementing this stuff, get these action tokens for Azure, and finally I found out that Azure doesn't have like SharePoint. I have to get a Microsoft 365 account. So this ChatGPT 4 is really interesting, really helpful, but you have to be careful because it sort of imagines stuff. But it works for some of the cloud technologies. But it's got like only up to 2021 November. But for some of the code, it's crazy what it can do. You can give it a bunch of code and say refactor it to do this. And I pretty much use it all the time now. So.
And what do you use the chat input, or do you use something like GitHub? What's it called? Codex, GitHub Copilot.
I use both. So sometimes when I'm writing the ChatGPT input inside of a WebStorm, and it's using GitHub Copilot to generate the text, and then I copy that into ChatGPT. Last night I actually reached my bandwidth of 30 messages per 3 hours, and it actually says you can ask again in 10 minutes, but it's such a productivity boost, like, you know, yeah. And Austria are rolling out some kind of like government pods for your data now. So everybody has like, all the citizens have some of the details up there, but now like more and more things are going onto these pods where you put your data on the cloud, and there's like some common data interface that things can access. So I think Tim Berners-Lee's doing a conference in Germany about it, like it's Web 3.0. I don't know too much about it. Yeah, they've already put like I think all the citizens have their passport and driving license on these pods. Yeah, already. It's kind of scary, man. Like, I don't know. It's just like, okay, trust the government to put your data up there and hope nobody hacks it, you know?
Well, I mean, you're currently doing it to Facebook, right? You trust all the data to Zuckerberg, so I don't know what's better.
It's not news yet, but speaking of AI, I think the EU is currently discussing a law to regarding how AI can be used in public sectors, or how biometric analysis can be used. So I'm not sure.
Oh, to introduce ray guards, right?
Exactly, exactly.
Yeah, big things coming up, I guess. Let's see. Perhaps next meetup, only robots will sit here and talk to each other about ChatGPT.
And then another robot will create a summary for us to read.
Yes, fine, perfect. Andreas, I'm really happy you're here. Stage is all yours. Thanks a lot.
All right. So thanks a lot for joining my talk on zero-waste cloud computing. All right. So first off, a few words about myself. My name's Andreas, and as you can tell from the swag I'm wearing, I'm working at Dynatrace. And as you can tell by my lack of shoes, my role here is that of a software developer. You will find the links to all my socials on my personal site. Initially, I wanted to start this talk by talking about maturity, but then I looked at this image again and thought I might not be the most qualified person to do this. So let's cut right to the interesting part. This talk will not be about a new shiny tool that will solve all your problems, but rather how the idea of zero waste might be applied to cloud computing. And what I want you to take away from this talk is a new perspective to challenge the status quo in all of your projects. So what is zero waste? When we had our first kid, we started to think a little bit about the future, or rather the future of our kids. And with climate change in mind, we thought, what is the impact we as individuals can have on the environment? Of course, it's not a lot, but the least thing we could do is be a good role model for our kids. And eventually, we came across the idea of zero waste. So zero waste is the idea of a lifestyle that aims to minimize the amount of waste we produce to an absolute minimum. Might not get to zero, but it's the awareness of all the sectors in your life where you can improve. You might have heard about this already. I'm hoping it's a more common, it's beyond my own filter bubble, to say it like this. And you might have heard about this pyramid. But actually, zero waste pyramid looks rather like this. It's separated into stages that should guide you whenever you thinking of consuming something or whenever you are thinking of buying something new. So what are the stages of the zero waste pyramid? They can be very easily we remember by this alliteration: refuse, reduce, reuse, and recycle. And it's visualized like this because the topmost stage is the most effective when it comes to reducing waste. Anybody has an idea what the last stage might be? It's the thing we want to prevent, and that's letting our waste rot on the landfill. So we will get to each stage later on, but the question is, what does this all have to do with cloud computing? Of course, data centers might produce some electronic scrap, but what I will focus on today is rather the energy that data centers consume. Because depending on how this energy is produced, this will produce waste or have a big impact on the climate. And yes, you could argue that data centers shifted to renewable energies, quite heavily actually, but maybe this renewable energy could be used in different places in a more effective way. So how much energy do data centers even use? Let's look at some numbers. The International Energy Association published this data in 2019, and it shows us the terawatt hours per year separated by the data center types. And it shows us that yes, people are moving towards the cloud. Usually you would say, follow the money. In this case, we follow the energy. But in terms of data centers, energy and money could almost be used interchangeably. So what we see is, one very nice thing we see is that the actual consumption didn't change that much over the last 10 years. It's in the single-digit percentage, although the request for cloud resources changed quite drastically. And this is, of course, because data centers try their hardest to reduce their energy consumption as much as they can. Because in the end, what they need to charge you is whatever they are paying for their energy consumption plus a small markup. So the more efficient they are, the cheaper they can sell their cloud resources to you. Now, I don't expect anyone to have a grasp on what 200 terawatt hours are in the bigger context. So on the global scale, all data center types combined are consuming 1% of the world's electricity. And it's a bit weird to put 1% on the slide and market it as a big number, but it should show you that this is significant. And this is just the data centers, not the infrastructure in between you and the data center, and it's also leaving out any crypto mining. So the IEA, the International Energy Association, showed that moving to the cloud already has a beneficial impact on has a net benefit effect regarding sustainability, but I think there is more we can do than just moving to the cloud. And it can even have the same effect as, or I like to compare it to energy efficient light bulbs. We switched from the wasteful, how would you call them? You know, our old light bulbs now to more energy efficient LEDs. But now we just installed so many more LEDs that it kind of canceled out. And what the graph I showed you before does not account for is new kinds of workloads that are now taking way more energy, like training large language models. So let's see how these numbers will evolve in the future. The data centers are responsible for 1%. The whole information and communication technology sector is about 2 to 3%, and its carbon footprint is bigger than the footprint of the aviation sector. So although we're talking a lot about long-distance flights when it comes to climate impact, we might also want to talk about data centers and the usage of cloud services. All right, so let's try to apply zero-waste principles to cloud computing. As you remember, first step was refuse. And this should be pretty straightforward, right? Just don't buy stuff. Or rather, try to realize, is it something I actually want? Or is it something I actually need? Or just something I want? I've been in this situation. Not with the iPhone, but you get the idea. Refusing could also mean to not go for an option that will create waste later on. Like for groceries, you might want to buy something that is not packaged in single-use plastics, but rather a reusable container, or maybe comes without packaging at all. There are stores like this, but you have to know them. So how could refusing consumption look in the cloud-native realm? To illustrate that, let me tell you about a weird project I was part of. In this project, the city of Vienna, or the Wien Energie, had the idea to sell shares of solar power plants. So far, so good. They wanted to sell those shares to their customers so they get the discount depending on how much energy will be produced in those solar power plants. Of course, this means you would need to measure the energy production, so you need to send this to some backend. And since they wanted to make this in the most modern setup possible, they used a Kubernetes cluster for one backend service and a small frontend. And of course, this needs to be stored somewhere. But since this is data that should be transparent to the users, they thought, let's store this on the blockchain. Now, this might not be the most efficient way to do this, and some might have argued that this could have just been a Kickstarter project and no software would have need to be built in the first place. But who would get this million in funding then? What I want you to take away from this story is the design phase is the place where you can get rid of a lot of waste. It's the place where you should raise your hand and ask, do we really need to store this on the blockchain? Do we really need yet another microservice, or could this just be a feature flag in the 300 services we already have? So take this perspective of sustainability and challenge your designs from that direction as well, just as you do with usability, security, and all those other aspects that go into a good design. Don't build things like this. Since we're bashing crypto already, let's look at the climate impact of crypto. should not be a surprise to you that crypto is taking a lot of energy. And in 2019, Bitcoin alone was responsible for 70 million tons of CO2 equivalents. Again, what does this number even mean? Let's compare it to something else. So this was mining fake internet points. What about mining real gold? Turned out in 2019 it was close, but still below actual gold mining. Now that's also a bit hard to imagine. But it turned out Austria was a bit below what Bitcoin used in 2019. And remember, this is a conservative estimate. So they, of course, try to figure out where miners are on the globe and what's the energy mix in those countries. It's hard to get a good estimate, but that's already conservative. Now, this was in 2019. The hype kind of ebbed down. So today's numbers are hopefully lower. Oh. They're even higher. So I think they even surpassed gold mining now. But again, that's Bitcoin. There are better examples, like Ethereum. Ethereum changed their consensus mechanism recently, and they changed from this wasteful proof of work towards the more efficient, yet still questionable proof of stake. And their energy consumption went from 21 terawatt hours annually down to 6 gigawatts. So again, these estimates are with large error bars, but it's safe to say they improved 1,000-fold. By the way, YouTube has an annual energy consumption of about 10 terawatt hours. I leave it up to you to say what service is more valuable to the society. That's maybe a different talk altogether. All right. Reducing was already one of the steps on the zero waste pyramid. Again, reducing should be simple, but in practice we all know how hard it can be to limit ourselves to just what we buy just the things that we need. And I guess you have been in this situation as well. So what I challenge you to do is observe your fridge and figure out how much food you actually need and how much goes to waste week by week. I mentioned observability because it's key to reducing your consumption in cloud resources. So not every project I've been part of has been this as crazy as the one I showed you before. I've also worked for Wahlkabine.at, which is a voting advice application. And here you can see the users per day, or rather the questionnaires per day. So this was a page that allowed you to match your beliefs to those of political parties in the form of a questionnaire. And it hopefully gave you some advice on how to vote. Now, if we just look at this graph, we might think that, okay, if there is a national election, like at the end of September 2019, we might start off with X amount of servers, and maybe we need to double them towards the end of the month. But the actual picture looks way different if we zoom in, and luckily I don't need AI to do this. This is the same usage on an hourly basis, but I can even go one step further towards the minute basis. And now we see that actual usage patterns or actual load spikes can be rather short. This means that when you think of, when you make your system scalable, you should be aware of how fast you are able to scale, because these spikes can come in the matter of minutes, how fast you can detect them, how fast your system can actually scale, and also how far you can scale down your system to not waste any resources during the night times. Maybe you're operating on a global scale. In this case, you need to adopt this to all the geolocations and maybe scale down Europe to the night times while your Asian data centers are up. So I also have the same data for the 2017 national election, and in this case I was able to attribute the load spikes to events. So yes, being mentioned on Twitter is not foreseeable, but a press release that you issue yourself, you could have foreseen that. Being mentioned in the evening news was also something that was planned, and being mentioned on the radio in this morning show, again, was something we already knew about. So if you have a marketing department, you might want to talk to them when they issue a new campaign, and you might want to turn up your servers right before they post on the social media. There is an interesting open source project called KEDA that lets you scale your Kubernetes clusters on all, depending on all kinds of events. And there's even an external event source. So you might even be able to scale your system depending on when you run your ads. But I'm pretty sure you have even more ideas. In any case, you need to know the usage patterns of your services to know when you need your resources and when you can shut them down. And actually, you should also do this maybe for your staging and dev environments, because I'm guessing your developers are not working during night hours, or at least not at 4 in the morning, and hopefully not on weekends. There is another rather new tool I want to present, and that's called the Cloud Carbon Footprint. It's also open source. It gives you observability on a bit of a different perspective. In this case, it tells you which of your hosts are currently idling. Now, this doesn't mean that they are not used, but it just shows you that they are underused. So it tells you where you need to look closer to figure out if you might want to improve the scaling, or if you might want to shut them down altogether if they are part of some bigger cluster. So again, observability is key to know where we can reduce our resource consumption. So let's say we refuse to build something stupid and we scale down as far as possible. What else can we do? Reusing resources means not putting in the energy to build something totally new, but rather repairing something to prolong its lifetime or buy something second-hand. Again, in practice, this should be pretty simple, but we all know how hard it can be to rather go for a used option than buy the new shiny thing. Again, how can this be applied to the cloud, to cloud resources? So I was thinking, how does the request of a user flow through your system? They enter you through the internet, go through a number of microservices until they reach some data source, which then returns some view on this data. It gets processed and sent back, and you might load a whole bunch of other resources. Now, what can we reuse here? Or how could reuse look in this scenario? And it's rather straightforward. You try to cache on every layer. You try to cache as much as possible. And the points where you can cache are those where the response or the computation result is not yet specific to any specific user. This could be the render result of your front page. Might not change every second, so you might want to cache that. What else? You can use, you can think of all the other resources that go into your web application. Then also think of what resources does your customer already have on his machine. Fonts, for instance, might be a good idea to not reload for every different web application. So if you use all the built-in fonts, it gives a more native look and feel and saves you from serving more or less useless files. Packaging your front end differently might prevent you from shipping the same framework code over and over again to your customers for every update. So if you spend a few hours into configuring your bundlers, you might end up rather with a libraries, polyfills, and application code bundle, and you would only ship the updates that are really relevant for your customers. And there are techniques for native apps as well that allow you to bundle just the things that are relevant for your customers. Now, what about recycling? Again, pretty straightforward idea. In theory, we use all the materials of our product and make something new out of it. Yes, this takes some energy, but at least the raw materials don't go to waste. But as we all know, in practice, that's way more difficult than it sounds like. Now, how could recycling look in the cloud native world? When I thought of, so the difference between recycling and reusing is mostly that when you have something recycled, it's of less quality than the original product. It can still be the same product, like recycled paper. It's again paper, but it has not the durability of the original product. In the same way, there are cloud resources. No, wait. Let's start differently. Bakeries. Bakeries need to produce more than they actually can sell on any day because they cannot perfectly estimate how much their customers will buy. So they will have a little bit of leftover at the end of the day. And there are great applications like Too Good To Go that allow you to buy off these second-grade goods at a large discount. And the same thing exists in the cloud. So Amazon also needs to provide more resources than their customers actually buy. So they are left with a bit of leftover resources which they sell as spot instances. Now, just as recycled paper is not as strong as the original paper, these spot instances don't have the same SLAs as the usual instances you could buy from Amazon. But of course, they come at a large discount. One thing that prevents a lot of customers from buying these spot instances is, of course, that they can be reclaimed by Amazon at any point in time. But you would get a 2 minutes notice before. So you would have time to shift away your workload or turn it off in a safe way. Now, if you think about what it takes to use these spot instances, the prerequisites are actually exactly the things our cloud-native workloads should already fulfill, meaning they're scalable, they're crash-resistant, they are stateless, hopefully. So you could use these spot instances to create a auto-scaling group that you attach to your Kubernetes cluster and make the Kubernetes cluster schedule or reschedule all the pods that are running on those spot instances should the event come that this node will be shut down. In this case, the extender module or mechanism of Kubernetes can just ask for a new spot instance to reschedule all the pods before it gets shut down. And if your startup time is below, or if your shutdown time rather, is below 2 minutes, you should be good to go. So I now presented you with a lot of more or less weird ideas on how to save resources. What I hope you could take away from this talk is, as I said, this mindset of not only thinking about your resources from the customer side and thinking about performance, but also with your with sustainability in mind. And I hope you will prevent a lot of energy and resources from ending up wasted or as or as real and products would end up in a landfill. So, as I said, zero waste is not really expecting you to reduce your waste to absolute zero. The same way, I think we cannot reduce our energy consumption to zero. But what I want you to do is be mindful of where we can reduce our consumption and where it really makes sense to invest in resources. And if you need more ideas than what I presented to you today, you should check out this newly formed technical advisory group of the Cloud Native Foundation. They formed last year in October, and they released a white paper outlining all the efforts regarding sustainability that already exist in the cloud native landscape. Thanks a lot.
Thanks a lot, Andreas. Thank you very much. Thanks a lot, Andreas, for this very important talk. I try now to give you a bit of insight what you can do when you want to be more energy efficient, especially on the web. And you said so many important things. Let me ask you a question. So, was there any decision that any of you did the last couple of months that you regret? Did you choose MySQL, for example? Anything else? Anything that you regretted? I have an excellent news for you. You cannot go wrong. I will show you the things that I show you today. You won't regret anything. You won't be wrong. You cannot go wrong. And I want to do a deep dive with you now. What I mean with that, and you'll see in a sec. So, I looked at the top websites. And you see Google, well, that's not too complicated, right? And there is Wikipedia, seventh biggest website. I mean, we all know it, right? It won't be something that will confuse us. Total page visits 4.5, and no, that's not ChatGPT. That's really the billion visits a month, by the way. So quite a lot. So let's look at Wikipedia. What is it? Oh yeah, we saw that, right? And there's this thing here. I think it's a graphic, right? Let's look it up. So I inspect the graphic. I hope I find image. Should be somewhere here. If not, I'll just look at the network. Where is it? Oh yeah, here it is. And as you can see, the image is a PNG, right?
Sorry, could you make it a little bigger?
Bigger? Oh, sorry. Oh man. Yeah, this image is what I'm talking about. Sorry for that.
No, on the bottom.
Oh my, how do I do this? Yes.
Thank you.
Command plus. Perfect, working fine. So let's look at the image. Oh yeah, nice. So this is a PNG, right? 4.5 billion views a month, and they show us a PNG on the start page. So let's download this PNG. And let's look at the stats. What is it? 15K, that's great, right? 15 kilobyte. All of you know WebP, I guess, right? It's quite a new image format. There are already successes on the horizons like AVIF and some JPEG thing, JPEG XL, I think. Man, they are around for a long time now. And so what I'll do is I'll just open up a converter and convert this PNG to WebP. So let's do that. Ingest Wikipedia logo with an output. I'm too lazy, so I just append a WebP. And then let's look at that. And we were able to reduce the size in half. And this is interesting. So we have 4.5 billion visits, 4.5 billion times. And I know, yes, it's an easy calculation because we have caching. I guess we have so many caching layers that we can't even grasp it thinking about it. But let's keep it more simple and just ignore the caching for a moment. And when we do the simple calculation, let's say everyone deleted their caches, then we send you the image 4.5 billion times a month. And it has double the size that it would perhaps need to have. So let's look up. I mean, one of the main reasons for that is perhaps that no one is using browsers that are able to support WebP, right? So I want to make sure WebP, where is it? Oh well, my. So at least 95% of people are able to see WebP images. Oh, that's strange. So you could ship the WebP file 95% of your time. That should save some things, especially perhaps money. Amazon pricing. We already talked about that today, right? Amazon pricing data transfer cost. And it's way more complicated. So data out to the internet. I guess Wikipedia has 150 terabyte a month. $0.05 per gigabyte. Oh God, I hope I'm able to calculate this now. All right. Whew. So what do we save? We save 7.4, which is we save 7.6 kilobytes times, oh man, 4, what is it, 4.5 billion, 5 million, now I think that's correct, right? Million, thousand, yeah, it seems good, does it? And now, of course, this kilobyte, we're not really interested in kilobytes, so we just say megabyte and or megabyte, and then gigabyte. Is this correct, by the way? No? Yes? So this is 34 terabyte, right? So this is one image in the size of 15K, generate, and we would be able to save 34 terabyte a month just by doing so. And let's see what this saves us in terms of cache. They want, well, I don't know if Wikipedia is using Amazon, by the way. I'm just looking up Amazon. So per gigabyte, we are at gigabyte, I think, so let's do the math. So one image generating not that much, to be honest, 1,410. Yeah, no, 1,710 US dollars a month. $20,000 a year. All right. And that's just one image. Oh, by the way, I'm sorry for that. We said that only 95% of people are able to see the WebP, so we of course need to have some kind of logic there. So 19,494. Yeah, I mean, you can't go wrong, right? Not only do you save your company money, but you also generate less traffic. Like you said, Andreas, I mean, generating less traffic, maybe we don't need that much infrastructure, and so on. It was really interesting to see this. It was really interesting to see this, and as I said, caching, I think, plays a big role there. So this calculation is not super precise. By the way, what I found really interesting is that when you hit up google.com and you see the Google logo, where is it? Oh, it's a PNG. And I guess caching is a big role why they didn't change it, but I don't know. Really interesting why this is a PNG. We'll never find out. Google, contact me, please. I'm really interested to know it. I really am. So this is a big thing in the topic of green coding, the page weight. So if you're able to reduce your page weight, you're able to reduce the traffic, and on the long run, you perhaps are able to reduce cost of infrastructure. Very important, because this is something that people misunderstood for a long time, and there's a paper that came out in 2020. I give you the sources afterwards. The general infrastructure that you need to provide internet access has, of course, power needs that are there. So the idling power needs are quite big. So we should not exaggerate the impact of your data in the power consumption. So there we need to be aware of that. So of course, if you only look at the networking hardware, and this was done by Ericsson, so they know one thing or two about networking hardware, right? And especially cell tower hardware. The idling costs are quite high, and the idling power consumption is quite high. And because of improvements in the hardware, I mean, we all saw the shift anyways with consumer devices as well. Apple moved to ARM and so on. We see RISC-V and so on. So the improvements there, of course, reduce the energy consumption. And there are graphs where you see that even though data consumption is going up, energy consumption is going down because of all the hardware improvements. So we really need to be aware of that, and it's not that easy. You cannot say because of reducing data, you reduce power consumption. That would be too easy to say. But when you look at the whole end-to-end cycle or end-to-end story, of course, when you reduce bandwidth usage, you maybe are able to reduce hardware at, I don't know, video stream portals like Netflix. You're able to reduce storage capacity at, especially when we talk about better and improved compression rates at Netflix and so on. So this matters. And lucky for us, we cannot go wrong because everyone is interested in reducing that. Because it not only reduces your impact in terms of energy consumption, but also, of course, your costs. And not only your costs, but also the cost of the providers. Nice, right? You cannot go wrong. Love it. Another thing, so the thing is page weight. How can we reduce the page weight? Another thing that's interesting is how can we reduce the time it takes you to find something. So, for example, let's say that you opened up. Anyone of you knows Bol? Oh, well, I guess it's bol.com. It's the Netherlands. It's a Netherlands Amazon. It's really cool. People in the Netherlands love to go camping, right? And Bol delivers packages right to the camping site. So if you're in the Netherlands and you need hardware, go to bol.com and they deliver it right to the camping site. It's really great. And that's, I mean, also here, you can't go wrong. Amazon and Bol and all the others, of course, they're interested in that you find the things very fast. And by finding the things you're looking for fast, you reduce, again, the consumption, the energy consumption, because you reduce the time that you're on the pages, you reduce the calls, the network calls, the API calls, and so on. So this is the second thing that we need to care about when we talk about green coding. Page weight and time spent looking for things. And the third thing, and this is very important, as this was somehow and now you see my buying history. Oh my, my kids love this hip vanilla thing. So well. But anyways, one of the conclusions of this paper, and I give you the sources afterwards, is that the end user device plays a big role. And in 2018 at the Android, I have it here at the Android Dev Summit, there was a talk about that. I really recommend it. I know it's just dissing Apple, whatever. But the most interesting thing is that Google moved, I guess, their Pixel to AMOLED. iPhone was still using LCD. I don't think even micro LED at that time. and they were able to reduce the energy consumption by 63% with night mode. And this has a big impact. And also the paper was saying that when you move away from such a display, perhaps it's an OLED display, so perhaps it's a super great display. I don't know about this display, but when you use to smaller devices and when you consume your videos on smaller devices, that's the main benefit to save energy. Because the small devices just use less energy. So if you watch the movie on the iPhone, and I don't know, I don't like it too much, of course, to watch my movie on the phone, and perhaps I won't do it, but watching it on the laptop would be way better than watching it on this, super cool screen, but of course, very power-consuming screen. So I definitely recommend you to watch the video. It's great, it has all the details in it, and Google definitely was faster there to move to something else than iPhone. In that case, AMOLED. Andreas, you talked about CADA, because the next question is, okay, how do we, when we look at the data center, how do we know how much we consume, how much data we consume? And there is something. Yes, Azure, Microsoft developed a carbon-aware CADA operator. You know about it, right? Yeah. And it's exactly what Andreas talked about. It's an operator that is able to do the scaling based on your carbon usage. Okay, and you would think, okay, what does this mean? This doesn't make any sense. Why would the carbon usage be different from one data center to the other? That's the first question that I thought about. And there's something cool called electricity map. I don't know if you know it. Honestly, I only used it on mobile. I don't know if they even have a website version. I think do they have a website version? I don't know. I think it's for free on mobile. At least it was. I won't subscribe there now. What it's giving you is it's giving you a map like this. Oh yeah, cool. I can go in. Nice. I just have to click on the map. And what you see here is you see where your energy comes from. So let's click on Austria, right? In Austria at the moment, and you see here that most energy generated comes from hydro, which is great, and a bit of energy generated comes from gas, and you also have a timeline for the last 24 hours. The mobile interface is a bit different. I don't know how to use it now, but you can see the last 24 hours on mobile, and you have the carbon emissions, and that's where the CADA operator comes in. So when you do a horizontal scaling over multiple data centers in different locations, you can say, all right, at what time is it? 6 p.m. 16. You don't want to host in, perhaps you don't want to host in Austria because the gas emissions are quite big. The carbon emissions based on gas are quite big. On the other hand, hydro looks good, so perhaps let's take a different country, Poland. Doesn't look too good. It's a brown thing, so I guess, yeah, lots of coal. So perhaps you don't want to use, scale up in Poland at that time. And you can use electricity maps to manually look at where the best locations would be, depending on the time of day. And of course, the CADA operator automates that for you. There are other tools. So this is the carbon-aware CADA operator. There are other tools like Kepler. It was just recently released to Sustainable Computing I/O. It was developed by Red Hat. It gives you an overview of what's going on in your Kubernetes cluster regarding energy consumption. And then if you need something like that for bare metal, then you could use Scaphandra. As you can see, it's a Grafana. It provides you with Prometheus metrics that you could use in your Grafana dashboard to look at the energy consumption of bare metal devices. So yeah, that's pretty much what I wanted to say. I hope it was interesting, and I guess we now can move to the Q&A. Andreas, I need you for the Q&A. Come to me. Come to the Q&A. I give you this, and I will move to the hand mic.
All right. quite interesting how much impact the end device actually makes.
Yes.
I mean, for this Wahlkabine.at project, the whole point was also to move the compute effort away from their tiny server towards the client, but rather because of performance reasons. But now I wonder if it's more efficient to not render on the server, where you might only render once instead of on all the clients. And I'm also wondering how these efficiency gains in the data center are holding up comparing to our growing use of the data. When I think of VR devices, where you now would start streaming not at 1K, at HD, but rather 4K, and you want twice the amount of data since you're streaming in 3D, or maybe even higher than this because you want the 360 view. So that's magnitudes of more data compared to previous use cases. And I'm really wondering, was this mentioned in the paper by Ericsson?
Yeah, it was mentioned. Sorry, I think I didn't give you the sources. Oh my, thank you. So let's do that just now. Sources. So this is the power consumption of mobile and fixed network data services by Jens Malmberg in Ericsson Research. And what they write is that this data, so there was this old metric, right? It was, I think, well, I have to look it up. I don't want to think.
Like
I want to.
per megabyte.
Yeah, but I want to give you the real, kilowatt hours per gigabyte. And what in the Ericsson paper, what Jens is stating that this was true for low bandwidth connections. There was more of a correlation between data usage and kilowatt consumption in low bandwidth, but at high bandwidth you already have so high idling costs that it doesn't matter that much anymore.
Mm-hmm.
So that was the gist of it. But please falsify me, read the paper, and then tell me if I was right or not, if I understood it or not. Any questions from you? Or input, comments?
Can I make a small comment?
Sure.
Should I come? Actually, regarding the point with the image conversion, I used to make the websites for the wedding photographers when I was in the school and on the first years of university. The main issue was the hosting, because nobody wanted to pay for it really. They never understood why they should pay for the hosting. But they used to publish, it's a wedding website, you have to publish the photos, whatever you have, and you have about 1-2 gigabytes on the hosting server. And regarding the 95% of the users, you can still keep the PNG if you want to keep the compatibility, or doesn't matter, because there is one tool. It's called Tiny PNG and Tiny JPEG. The thing is, I don't know how does it work inside. I was testing a lot. I was giving 5 megabyte JPEG, for example, like 3000 by 2000, just a normal photo. Tiny JPEG was able to reduce it to 150 kilobytes. And the quality was the same if I do the same compression in Photoshop to 1 megabyte or something. So the thing is, if you wish to have more settings, they're asking for the money, but for the regular web development, like if you make your own page or you make landing or whatever, you still have enough requests and you can keep the same format, not be worried about compatibility, but you get much better output rather than from Photoshop itself or ACDC, or doesn't matter. So there is just a small hint if somebody is curious about WebP compatibility. But personally, I started to use WebP because first of all, it was the interest. And when I was doing some projects commercially or for myself, I was already trying to compress as much as I can. Not only because I didn't want to pay for the hosting, just because if I could achieve the same, but technically it would be much less, why not? And it didn't take that much effort.
In VR, it's quite common, or in any kind of games, you would only render the pixels the user actually sees. And I mean, we can learn a lot from game development, but this is a thing we should apply to all websites. We should only send the pixels the user would actually see. And since on a mobile device you have totally different layout, you should use, I think it's called source maps, to offer different kinds of resolutions and aspect ratios of the same image to the clients, so they can pick the image that's right for their screen size. Because why would you need the full widescreen banner when you're mobile and only see 10% of the pixels anyway? And I think your example also, or for a lot of websites, I guess the images are far bigger than maybe even the JavaScript, depending on your framework choice. So I guess cutting down on images is really the biggest impact you can make.
Mm. All right. If you don't have anything else to add, do you have anything to add? I don't have anything, I guess.
I would say have a look at the Slack channel or get involved in the CNCF projects. Those
Yes.
are nice people. They publish good stuff. And if you want to get involved in something that's making an impact, if you contribute to technology that can reduce carbon emissions, and a lot of companies apply this technology, I think that's the biggest impact that you as an individual can make towards sustainability.
What's it called again? Is the SIG CNCF? What's it then again?
I would have to look it up. Search
just
for tech environmental sustainability. It's not a SIG anymore, it's a tech now. I think SIG is the old name.
Oh yeah, sorry. Nice.
Right.
Yes, that one.
And on the About page, you will find the white paper about the cloud native. It's still in version 0.1, but this is where they try to collect efforts and really try to have this holistic view.
Nice. Looks super. So thanks again. Thanks for you being here. Thanks, Andreas. Thanks, Dynatrace, for hosting us. I wish you a great night. I hope you have as good food as we have here. All the best.